Hi guys, welcome to section 1.5. Please make sure to have your warm-up completed before you continue on. All right, so as of right now, you should have all three problems completed. So number one is a clearing fractions problem. So you should multiply everything by the LCD of 42 and get an answer of 10. Number two is a word problem. So you should have put X as Jason, and everything kind of comes after that. And then you should get the three numbers 20, 10, and 80 as your final answer. And then lastly, you should get this expression for the combined total dollar amount Henry paid for his class fees. And I wanted to show you guys this real quick. I know we naturally use X as our variable whenever we're doing word problems, but this one specifically said he is taking W credit hours. I say this only to warn you on Alex. You have to use the variable they say to use if they happen to say it, or they'll mark you wrong. So I just want to show you guys how to bypass that little frustrating situation on Alex. So just make sure you guys are really paying attention, especially like on a quiz or a test or an exit ticket. I'm not going to go back and switch that for you guys, so please be adamant about being very particular with this stuff. All right, so what we're going to do in section 1.5 is first go over one topic in 1.4, I think it was, or 1.3. It was in 1.3 or 1.4. And then you're going to start with inequality. So again, this is from 1.4. I actually think, it says 1.4 here. I'm pretty sure it's actually from some of those longer topics in 1.3. So look back at that. So this is called as a distance, rate, and time problem that comes up several times in this actually entire course, like this entire year. And so we're going to start off today by introducing them, and then we're going to build on them in different chapters. So it says, David drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 7 hours. When he drove home, there was no traffic, so it took him only 4 hours. And they give us rates that his average rate was 27 miles per hour faster on the way home. So how far does he live from the mountains? So what we're going to be doing with each of these problems is make a table. Okay, so I think you guys have heard of this formula before, distance equals rate times time. We're just going to flip that over and do rate times time equals distance on a table. So here's what your table is always going to look like. So before you start any rate, time, and distance problem, you're going to always want to have this prepared. And I'll show you guys how to fill it in, and it becomes really easy to calculate your problems. So on top of your columns, it's going to be that formula rate times time equals distance. And we're talking about two things. So the two things we're talking about is David driving there to the mountains and then driving back from the mountains, or whichever way you want to word that, like to and from, there and back, whichever way. So now we get to reread the problem, and we're going to fill things in as we read it. The column that you're not going to ever, for right now until we get to different chapters, in this chapter we are not touching the distance column. So you need to fill in the rate and time columns, but do not touch the distance column yet. Okay, so again, let's reread it. So you drove to the mountains, there was heavy traffic on the way there, and the trip took 7 hours. So on the way there, the rate was 7. I'm sorry, not the rate was 7. The time was 7. When he drove home, there was no traffic, and the trip only took 4 hours. So we'll put 4 here. If his average rate was 27 miles per hour faster on the way home, so his average rate there, we'll call it X, because his average rate on the way home was 27 faster than that. So something has to be X, so then you can build on it to do your second one. Okay, and then now I want to know how far away does he live from the mountains? So once you read this sentence, at the end of your last sentence, you should have, again, all 4 of those little boxes filled in. And then after that, you're able to fill in your distance column. And it follows the formula. So it's X times 7 equals, and you just put 7X. You just multiply across according to the formula on top. So x plus 27 times 4 equals, you just can put 4 times x plus 27. So once you fill in the distance column, you're always going to ask yourself, how do these two distances relate to each other? Okay, so how do they relate to each other? Think about it logically. He drove somewhere and then he just turned around and came back. Those distances are exactly the same, right? If I walk somewhere and then I come right back, I walked the same distance. So what you're going to do is set those two distances equal to each other. So you're going to put 7x equals 4 times x plus 27. And all I have to do here now is solve. So we distribute, and we get x all by itself to get x equals 36. Okay, well that is not necessarily the answer. Sometimes that will be the answer, most of the time will not be the answer. So we need to go back and answer the question. So the question, the last thing says, how far away does he live from the mountains? So you're going to plug x into where we can find distance. So plug it into the distance column. Here, you could plug it into any one because these are actually the same numbers, right? Because they equal each other. So I'm just going to plug it into the 7x box to find my distance. So 7 times 36 is equal to 252. So he lives 252 miles from the mountains. And that is your final answer. So for example, I could have asked you, what is the rate? And you would have plugged that into the rate column. Okay, so I could ask multiple questions just based off of you finding x. So make sure you pay attention to the actual question at hand. All right, so now we can try number 2. So number 2, again, before I even start the problem, I can already start making my table. So I'm ready to go and read and fill in the 2 columns. And then on top of your table, you want to do rate times time equals distance. All right, so this says 2 trains leave the station at the same time, one heading east and the other heading west. So those are the 2 things we're talking about, going east and going west. Okay, and again, we are not touching the distance, so do not touch that, but we should fill in the rate and time as we read. The eastbound train travels 10 miles an hour faster than the westbound train. So you try to think to yourself, which one should be x? So we know that the westbound train should probably be x, because then the rate for the east one is 10 miles an hour faster. If the 2 trains are 340 miles apart, and I know you really want to put, because 340 miles apart means distance, so you want to put that in here, but I said do not touch that. That 340 will be used at a separate time, so just maybe circle it, but you're not touching the distance column. After 2 hours, so they both went 2 hours, so both of these are actually going to be 2. We want to know the rate of the eastbound train. Okay, so again, after reading the problem, I should have all 4 of those boxes filled in. We now multiply across to get my distance columns, which is easy enough. And now we have to write an equation that compares those 2 distances. Okay, it's not going to always be like how we did above where you equal them to each other. It's going to be different depending on the problem. So think about it logically. So we have 2 trains that start at the same time. One went left and one went right for 2, they both went for 2 hours. Obviously one was faster than the other, like the east one is a little bit faster, so it goes a little bit longer, right? In theory, it goes a little bit longer distance than the slower train. So the distances are not the same because obviously this train went a little bit farther than the other train because it went faster. So we can't equal them to each other, but that's where this 340 comes into play. We know that if we add these 2 trains together, in total, they covered 340 miles. So I want to stop here. So this is your 2 options you have with these word problems. You're either always going to equal them to each other if they went the same distance, or you add them up and set it equal to a distance that was given to you in the problem. So those are your two options. So now we just go back to the problem. We're going to go on and solve it. So just distribute, combine like terms, and divide to get x equals 80. And again, that's not necessarily your answer. So let's see what the answer is and see where we can plug it in. So the question was, what is the rate of the eastbound train? So the rate of the eastbound train is this expression here. So all you have to do is plug in 80 to that box. So you're going to get the rate of the eastbound train is 90 miles per hour. And that is your final answer. So pause here and try number 3 all by yourself, and then return back once you have found the answer. Okay, for number 3, make your 2 charts, and you should get 1.6 hours for how long it will take the 2 trains to be 272 miles apart. Okay, now we're going to learn 2 different notations that you guys are going to use the entire school year. So I cannot stress this enough, how important just knowing how to write this stuff is going to help you answer the questions, because you're going to get to a point where you're going to get the right answer, but if you don't know how to write it mathematically for us, it will be marked wrong. Okay, so it's really important to learn how to write this stuff mathematically. So we're going to start off with something called a set builder notation. A set builder notation looks super mathy and like math like language. So it looks a little bit complicated, but I promise you it's pretty easy to understand. So we're going to call it like something that's a list of numbers is called a set. So set T is just like a list of numbers. So you write T equals, and you're going to get really used to writing these little curly Q brackets. They're going to be tough at first for you to write, but you're going to use those little curly brackets. And this is how we read it. So when you see this L here, this is read as such that. So we're going to read it left to right. So T equals Y such that Y is an integer, so just like whole numbers, and -1 is less than Y, which is less than 4. So this is that yellow highlighted is called your set builder notation. So what does this really mean? So I broke it down for you guys in the next section. It says we need to list all the numbers Y that satisfy the following conditions. So it said it's an integer, so we're going to list all the whole numbers that are greater than -1 but less than 4. So numbers that are greater than -1 and less than 4 are 0, 1, 2, and 3. And again, these are in your curly brackets. So this notation is called your roster notation. Think of it like as a roster of like athletes, like you just listed all the elements in that set. So we just went through set builder, roster notation, and then we're going to go through interval notation before I do this section. So interval notation, this is the most important, cannot stress this enough. The most important notation, you're going to use this so much this year. So we're going to graph like on a number line like you guys used to in, I feel like middle school. Like we have like a number line like this and you have like an open or closed circle, some of that stuff like you did in Algebra 1. So this relates to graphing on a number line. So you're going to have to do that for all the problems from here on out. So as a reminder, if you use less than or greater than symbols, you're going to use an open circle on a graph. And that's going to relate to your interval notation that you need to learn now as parentheses. That is different than if you use less than or greater than or equal to symbols or inequalities. So notice like the line on the bottom changes it to a closed circle on a graph, which equates to interval notation using brackets. So you're like, what is all this going on right now? I'm going to show you guys and break it down for you right here. So it says, example, rewrite the set L by listing its elements. Then we're going to graph it and write an interval notation. So all your notations are going to be broken down right now. So again, This is called your set builder. Now let's do the roster notation. So it's set L equals, we're going to start our curly brackets. So it says it's an integer that is greater than -3, but less than or equal to 0. So our roster, like our players in that set, is -2, -1, and we could include 0 since it said less than or equal to 0. So that's our roster. We're going to graph this. And when you graph an inequality like this, you just use like the two numbers it gave you. So -3 and 0. As a reminder, so it's going to say less than on the -3, and then the 0 had a less than or equal to, so you fill it in because that's the equal to part. And you just connect the dots or the space in between. So that's your graph. And how you do your interval notation is always from your graph. So the -3 has an open circle, so that equates to a parentheses. And then you do comma, and then the 0 has a closed circle, so you do a bracket. So your interval notation only always has two numbers. It has the number on the left-hand side and the number on the right-hand side, and that's it. Okay, so that kind of just broke it down for you. So we're going to practice a little bit more before we start actually like learning the math part of this. So now it says number 1, graph the set x such that -7 is less than x is less than 0 on a number line, and then write it using interval notation. Okay, so again, you just use the two numbers that are listed. You don't have to do all the numbers in between. Pay attention to these symbols. He's going to tell you if it's open or closed circles. So these are both open because it doesn't have the equal to part on it. And then you just fill in all the space. You can like fill it in like this. I just like to make a line, but you just have to show that you're filling in all the space in between -7 and 0. So interval notation always goes left to right. So you always start at your left number, which is -7, and I put a parentheses because it's an open circle. And then you do comma, the right number, and again, that's parentheses as well because it is an open circle. Okay, so again, that looks like a coordinate plane if I was plotting it. This is something totally different, but they are going to look a lot alike. Number 2 says graph the set x such that -1 is less than x, which is less than or equal to +6. So we're going to graph it first. And now pay attention to open and closed circles. So these again are your symbols that are going to tell you if it's open or closed. So the -1 is open, and then the 6 is closed because it has that equal to part on the bottom. Okay, and you fill in the space in between to show you that's all the integers in between. So now we use the interval notation, always going left to right. If you go right to left, you'll be getting it wrong. Always left to right. So the left number is -1 with the parentheses because it's open. And then you go 6 and it's closed, but with a bracket. That's how I can tell by looking at my answer if it's going to include 6 or not include 6. So if I was doing my roster notation, this would include the number 6 because I see a bracket and a closed circle, meaning 6 is part of my set. So pause here and try number 3 all by yourself. All right, so now that you guys know how to use your interval notations and graphing carefully, you're going to actually now solve inequalities, and then we're going to graph and do interval notation with these. So I know you guys know how to do linear inequalities because you learned this in Algebra 1, and it's basically the same thing you would do if you had an equal sign. So you just treat these exactly the same if you had an equal sign. We're just going to add the graphing and the interval notation at the end. Okay, so if I want to get z by itself, I would add 6 to both sides, so z would be less than 21. Okay, but that's not necessarily your answer. That could be your answer, but not necessarily. So you actually always have 3 answers for these. Now we're going to graph it on a number line. This is going to be an open circle to the left. And if you write your variable on the left-hand side, like z is on the left-hand side, the symbol of your inequality actually shows you where to point your arrow. So that always goes together. Something you should have also learned in Algebra 1. So now we write the interval notation, always going left to right. But we need two numbers, right? Above we had two numbers to deal with. We only have 21 to deal with. So where am I going to get my second number? Well, if we're going left to right, if you notice, this line goes all the way left to negative infinity, is technically all the way forever on the left-hand side. So if a line extends all the way, you're going to start with negative infinity, and then it goes to 21 with a parentheses, not a bracket. And then just to let you know, infinities and negative infinities always will have a parentheses. Those do not have a bracket because technically we don't know what that value of infinity is, so we can't include it in our set. So we will always have a parentheses attached to it. Okay, so those are your three answers. Because, for example, on Alex or your test, I could ask you for the inequality. That could be your answer. I might ask you for the graph, or I might ask you for the interval notation. So all three of those are eligible to be the answers. So that's why I have to go through all of them for practice. All right, number 2, solving for x. So add 6 to both sides, you get 6x is greater than 0, so x is greater than 0. So the solving part is not what I'm worried about. I'm worried about you guys writing these in notations. So for practice, we need to do the graph. So open circle on 0 to the right. It's all the numbers that are greater than 0. And then we write this in interval notation. We start at 0 because we're going left to right. Left is 0 with a parentheses, and then it goes all the way to positive infinity, always with a parentheses on infinity. Number 3. So we're going to add 34 to both sides. You get 15 is greater than or equal to negative 3y. And then up here on your notes in highlight, so it's really important, remember that you can only switch the sign. You're going to switch the sign if you are multiplying or dividing by a negative number. So here, for example, if I want to get y by itself, I'm going to divide both sides by negative 3, which is going to switch my sign. So it's greater than or equal to right now. It's going to become less than or equal to. And then you just continue on how you normally would. So divide by negative 3 would be negative 5, and you have a y here. Okay, to me, when the variable's on the right-hand side, it seems confusing for me to interpret what the graph will look like. So I just like to switch it around and do y on the left-hand side, and then you switch everything else. And if you're like, oh, there's too much switching going on, just think about like where the mouth of the inequality, so like the mouth I say is like facing y, it's opening up to y. That way if I switch it to over here, they mean the exact same thing. So I would suggest writing it to the second version. That way I can graph way easier because I understand more logically what that means. So in this way, it's going to be a filled in circle now because it's greater than or equal to negative 5. And this goes to positive infinity. So my interval notation will be a bracket, negative 5, because it includes negative 5, all the way to positive infinity with a parentheses. Number 4. So subtract both sides by 45. I should get negative 30. W is less than negative 6. So we have negative 6. It's going to be an open circle to the left. All the numbers less than negative 6. So going from left to right in my interval notation would be negative infinity to negative 6 parentheses. All right, getting a little bit more complicated by having multiple distributions, but that's okay. It's not going to throw us. So negative 11, distribute, plus 15 minus 5u less than or equal to negative 2u minus 14. combine like terms on the left-hand side. And then bring the u over. Going to isolate u. And notice again, this is like where people can make sloppy mistakes. I'm dividing by a negative, so I'm going to remind myself by switching the sign. So then u becomes 6. And now we go to graph it using a closed circle to the right. And then my interval will be bracket 6 going to positive infinity. So pause here, try number 6 all by yourself, and then return back for your answer. All right, for number 6, you should get -5 to positive infinity. All right, so the only difference between these and then your fraction ones are just, we're just making it complicated by reminding you guys to clear fractions. So remember, linear inequalities are the same thing as if you had an equal sign. And this is exactly what you guys did for number 1 on your warm-up today, right? You just cleared fractions and solved. Same idea, don't let the inequality part throw you. So we're gonna clear fractions first. So the LCD of this problem is going to be 12 because we have 4 and 6. So I'm gonna write 12 in front of everything. And then we're gonna be ready to go. So 12 times 3, because there's nothing to cancel out. So I should get 36. 4 goes into 12 3 times. So -21w. We're not going to cancel anything out here because there's no denominator. And then 6 goes into 12 2 times. Okay, so again, at this step, we should have no fractions and we're just going to be ready to solve. So now this problem looks like the problems you're just doing above. Okay, so there's only one extra step by clearing fractions here, and everything else should go very smoothly. Okay, so we're going to bring over the 36 to the other side. So then W, we are dividing by -4, so we switch the sign. 34. Oh, I don't know where my 5 went. -45. Sorry about that, 45. Okay, so W is greater than 34 over 45. I won't go over intervals or graphing on these ones because these tend to be fractional answers, and that's totally fine. And we could totally do interval notation and graphing with this, but we got enough practice above, so we'll just do the inequality for these ones. Okay, so number 2, we're going to clear fractions because, again, you should start getting in the habit with the whole rest of the year. If you see fractions, clear them. If you see fractions, clear them. Okay, so what we're going to do is multiply everything here by 24. That's what the LCD on this one is. Okay, so 24 times 2, nothing to clear out there, is 48. 8 goes into 24 3 times, so we're going to get -9x. And then nothing to clear out on the 24x. 6 goes into 24 4 times, so we have plus 20. So let's bring everything to each side. So you get 28 is less than or equal to 33x. Again, when I'm solving problems, I take it as you guys know how to do this already because it's Algebra 2 now. So I solve problems really quickly, but setting it up is something I'm trying to teach you. So if you need to take longer than what I'm doing, please always do. So now your answer is going to be 28 over 33 is less than or equal to x. Again, this means the same thing as doing x is greater than or equal to 28 over 33, which I just prefer more because I understand what that means more. I mean, oh, all the numbers greater than that. So that's what I like to transfer it over to. So pause here and try number 3 all by yourself. All right, number 3, you should get u is greater than or equal to negative 33 over 19. Or, oh, did I not? No, I did fine. Or the opposite way, which is this way. Okay, and then be careful. You might have assumed that you're switching the sign, but you're dividing by positive 19, not a negative, so your sign stayed the same. Okay, so either one of those highlighted answers are fine. I probably prefer more the right-hand side, but either way is fine. All right, so now you guys can start your ALEKS topics on 1.5.